In this video, I'm going to discuss the system of first order partial differential equations. We write system of partial differential equation like this: partial q vector by partial t plus a partial q vector by partial x is equal to 0, where q vector takes a value from R cross R as an input, and the output is R raised to power M. So we need to understand this system of partial differential equation throughout this course. Here, the Q under this definition will be written like this: Q R. For R, we have X and T. Since Q depends on T, and the output is a vector Rm, and that vector will be Q1 function of X and T, Q2 xt, and as you can see is in output we have R raised to power M, so the output will be a vector of M components: Q, M, X, T, Q1, xt, so on. So this is the way that we defined a vector valued function. Vector valued function, and this is a famous definition in multivariable calculus, where you give an input as a real number and the output is a vector, then that function is called vector valued function. On the other hand, if Q depends on X and T, but the output is a scalar value, then that function is called real valued function. And this definition is coming from the multivariable calculus as well. So let me just discuss this equation. Throughout this course, as I talked about earlier, this equation will be a model problem for advection equation. So we need to understand this equation. Since Q is defined like this, so we can write partial by partial t Q1, which is a function of x and t, Q2 x and t, and then we have m components. Q vector has m components, qm xt, plus A will be any matrix. I will talk about that later on. A is, I'm sorry, there should be partial by partial x. Then you can write Q1 xt. I can remove that. Q2 xt up to qm xt is equal to 0. So when you open this equation, you will get m system of first order equations. For example, we have partial q1 by partial t, and we have, for example, this matrix A. I should write this, for example, let me just write it in this way. Suppose I have A is equal to A11, A12, A21, A22, which is a coefficient matrix. And remember that in future we will talk about this coefficient matrix a lot. Then the Q vector will be, since we have two rows in matrix A, this Q will be equal to Q1 and Q2. And then we can write, for example, partial by partial t, Q1 xt, Q2 xt plus A11, A12, A21, A22, and again we have over here partial Q1 by partial x, partial Q2 by partial x, O is equal to 0. When you solve this equation, we get partial Q1 by partial t plus A11 partial Q1 by partial x plus A12 partial Q2 by partial x is equal to 0. Partial Q2 by partial t plus A21 partial Q1 by partial x, A22 partial Q2 by partial x is equal to 0. So in this way, we have a system of two partial differential equations, and we need to understand this system of first order PDE. Here, if I talk about what is Q vector over here, Q vector, since Q vector depends on x and t, and the output is vector like this, x and t and x and t. So this can be written as x will belong to real number r cross, and t belong to real number r cross r, and the output will be, in this case, r square, since we have two elements over here. Thank you for watching.